Howdy, stargazers, and welcome to Star Trails. I'm Drew, and I'll be your guide to the night sky for the week of August the 31st to September 6th. This is a week when the moon climbs from half-lit to nearly full, brightening each evening, and the outer planets take center stage. We'll also wander through a few oft-ignored constellations that hold some real treasures for small scopes and binoculars. Later in the show, we take a look at time, from the watches worn on space missions, Martian days, and the time-warping science behind GPS satellites. Whether you're tuning in from the backyard, the balcony, or just your imagination, I'm glad you're here. So find a cozy spot, let your eyes adjust, and let's see what the sky holds for us this week. We start with our nearest neighbor. The moon reached first quarter in the early hours of Sunday morning, and now it's waxing steadily through gibbous all week. By Saturday, it's a brilliant lantern, nearly full, with the official full moon arriving on Sunday the 7th. So your deep sky hunting windows shrink quickly. Favor the first half of the week if you want darker skies after midnight. Farther away, Saturn is a best bet right now. It's glowing in Pisces all evening, a bright golden ember. The rings are still at their thinnest in decades, edge-on and knife-like, but still a thrill in any telescope. Saturn reaches opposition later this month, so it will only get better. Neptune, also in Pisces, is nearby for late-night telescopic hunters, and Uranus comes up after midnight in Taurus. Mars is a low ember in the western twilight, hard to spot, but technically present. Meanwhile, the mornings belong to Venus and Jupiter. Venus continues as the dazzling morning star, while Jupiter rises earlier each night and sits near Gemini's bright twins, Castor and Pollux. A fine pairing to greet the dawn. If you're out in the early hours Monday morning, keep an eye on Aurigid for the Aurigid meteor shower. It's usually faint but has a history of surprise outbursts. And in the same part of the sky, Comet Lemmon, C2025A6, is sliding near Gemini. It's faint now, more a telescopic quarry, but worth noting as it brightens toward October. The brighter moon pushes us toward star clusters, doubles, and brighter objects that punch through moonlight. In Delphinus, the little diamond-shaped dolphin high in the southeast, you'll find two globular clusters, NGC 6934, a compact grainy ball, and NGC 7006, a distant halo globular so far away it appears as a mere smudge in the eyepiece. Slide westward to Sagitta, the tiny arrow pointing between Aquila and Vulpecula. Here you'll find M71, a cluster that sits right on the border between open and globular, granular, loosely packed, and striking at medium power. Up in Vulpecula, telescopes reveal NGC 6940, a lush field of faint suns. In Scutum, the wild duck cluster M11 is one of the sky's finest open clusters with stars packed like glitter. And for a challenge, hunt nearby for IC 1295, a delicate planetary nebula that responds beautifully to an O3 filter. Faint little Aquilius, the little horse near Delphinus, offers a fine double star, Epsilon Equili, a classic seeing test. And in Lacerta, the lizard crawling high overhead later at night, NGC 7243 sprawls as a pleasing scattered open cluster. The Milky Way still arcs bright through the south in early evening, but the moon's glow will wash it out more and more as the week goes on. Take advantage of the first few nights after midnight for darker glimpses, then shift your focus to planets, clusters, and lunar landscapes once the moon dominates. Next week brings the full moon and elsewhere in the world a total lunar eclipse, but it's not visible here in the Americas. Let's take a break from the sky and talk about something we can't escape, no matter what planet we're on: time. Here on Earth, time feels fixed. The sun rises, the sun sets, and our clocks keep a steady rhythm. But once you leave Earth, or even just start thinking like an interplanetary explorer, time starts to slip and bend in ways that are both subtle and profound. Let's start with Mars. A Martian day, or what scientists call a sol, lasts 24 hours, 39 minutes, and 35 seconds. Only about 40 minutes longer than an Earth day, but enough to wreak havoc on human schedules. Whenever NASA sends a rover like Spirit, Opportunity, Curiosity, or Perseverance, the mission team shifts to Mars time. Their schedules drift by 40 minutes each day, so within a couple of weeks, scientists are working the night shift, then the day shift, then back again. It's a jet lag without ever leaving Pasadena. Families of engineers even reported being pulled into this Martian rhythm, living in a haze of perpetual time zone changes. It's known as Martian insomnia. The engineers at JPL actually commissioned Mars watches. They look like ordinary chronographs, but the second hand ticks just a little slower, stretching the day to match a sol. It's one of the few times in history people have worn a watch calibrated to another planet. And that brings me to a portion of the show I call Watches in Space. First off, I'm a geek when it comes to watches in general. Watches worn by astronauts are a niche interest of mine, one that peaked a few years ago when I saw in person the Omega Speedmaster worn by astronaut Charles Duke. I once had the opportunity to meet shuttle astronaut Clayton Anderson, and I spent most of that time talking to him about ham radio on the ISS and, of course, his Omega X33 watch. The tradition of timekeeping in space runs deep. Early in human space exploration, NASA selected the Omega Speedmaster chronograph, a fully mechanical hand-wound watch. Mechanical watches can't crash or short out in a vacuum or when exposed to radiation. Additionally, the Speedmaster has an acrylic crystal, that's the glass over the dial, which is shatter-resistant, unlike the sapphire crystals that are often used in luxury timepieces. In old mission photos, you can see astronauts wearing the Speedmaster strapped over the wrist of their spacesuit during Gemini EVAs and on moonwalks. My favorite image of the Speedmaster was taken on Apollo 11, being worn by Buzz Aldrin inside the command module. Once on the lunar surface, Neil Armstrong actually left his watch in the lunar module as a backup timer, so it was Aldrin's that became the first watch on the moon. If you've seen the film Apollo 13, you might remember when a crucial course correction burn was timed by the stopwatch hand on the Speedmaster, or Speedy as it's affectionately known in watch nerd circles. Omega has embraced this history and still produces the original Moon watch to this day. They include a NASA-style nylon strap you can attach for real astronaut authenticity, along with the engraving "First Watch on the Moon" on the case back. If you have $7,000 or so burning a hole in your pocket, it can be yours. Or you can buy the plastic look-alike Moon Swatch for about $270. This one is a special edition from Omega's parent company, the Swatch Group. If you grew up in the 80s, you might remember the Swatch watch, those colorful plastic timepieces that were all the rage, along with neon colors on everything, parachute pants, jelly bracelets, and trapper keepers. The Omega isn't the only moon watch. Bulova makes a version inspired by watches worn on the Apollo 15 mission, although it eschews the mechanical innards for a super-accurate, high-beat quartz movement. NASA isn't as picky about watches nowadays. Crews have worn Zens, Fortises, and even digital watches. Today, astronauts often bring their personal watches like Garmin's and Apple watches. But the core idea is the same. You need reliable timekeeping when every maneuver, every engine burn, and every oxygen check is a life or death. And there's just something kind of cool about knowing that something as everyday and ordinary as a wristwatch can be used as a tool for space exploration. But what happens when you need extreme precision? Right now, your phone's navigation app depends on clocks in space, the atomic clocks onboard GPS satellites. Each satellite carries multiple clocks tuned to within billionths of a second. The system works by measuring how long it takes signals to reach your device. Even the tiniest error in timing would put you miles off course. And here's where relativity sneaks in. Einstein showed us that time doesn't tick the same everywhere. If you move very fast, your clock slows down compared to someone standing still. That's special relativity. If you climb higher out of a planet's gravity, your clock actually ticks faster, and that's general relativity. GPS satellites are in both situations at once. They're zipping around Earth at nearly 9,000 miles per hour, which makes their clocks run a little slow. But they're also about 12,500 miles above Earth's surface in weaker gravity, which makes their clocks run a little fast. Add the two effects together and the fast wins. Their clocks tick about 38 microseconds ahead each day compared to clocks on Earth. That sounds tiny, but if engineers didn't correct for it, your location on Google Maps would drift by several miles in a matter of hours. In other words, without taking relativity into account, we'd all be lost. So whether it's engineers struggling to live on Martian time, astronauts strapping Speedmasters to their sleeves, or atomic clocks whispering to your smartphone, space reminds us that time is not universal. It's a local rhythm tied to gravity, velocity, and the turning of worlds. Here on Earth, we march to a 24-hour beat. On Mars, the tempo slows by 40 minutes. In orbit, atomic clocks tick just differently enough to keep us humble. Time is not some absolute metronome in the background of the universe. It's pliable and contextual. And as we push farther into space, we'll discover just how many ways we can bend it, stretch it, and live by it. If the stars spoke to you this week, or if a question's been on your mind, I'd love to hear it. Visit our website, startrails.show, where you can contact me and explore past episodes. Be sure to follow us on Blue Sky and YouTube. Links are in the show notes. Until we meet again beneath the stars, clear skies, everyone.